Hi folks, we've got another lesson here. This is for Unit 4 and we're on Lesson 8. We're going to look at solving equations with substitution. And this is a way that we can work backwards, which we have been doing a number of times already, but working backwards with different formulas to find out some missing information. We're going to look at a number of different types of examples here. So the first question, it says that we want to solve for the missing dimension if the area of this shape is 234 centimeters squared. So my missing dimension down here is my length. I'm told the width is 16 and the length is my missing side, but I know that the area is 234. So what I'm going to do is write out an equation that links these things. I have a length and a width and an area. So I know that for a rectangle, area is length times width. Then I'm going to take the things that I'm given, the information that I'm given, a width of 16 and an area of 234, and put that into the equation. So 234 equals length times 16. And I think most people here would be able to kind of work backwards or pattern backwards. You might want to rewrite this as 16L. We're more used to seeing the numbers in front of the variables than vice versa. But this is a pretty straightforward equation to solve. We need to get L by itself, so I'll divide both sides by 16. So 234 divided by 16 ends up being 14.625 centimeters. So really what we're going to be doing in this lesson is just working backwards from a formula that we're given. We're going to have some of the information in the formula plus normally like the answer or what the formula will equal, and we'll have to do opposite operations to solve from there. Okay, the next one says solve for height if the area is 68 centimeters squared. So again, this is that one formula for area that tends to trick people a little bit. It's the trapezoid a plus b times h divided by 2. And in a diagram of a trapezoid, we usually label A on top and B on the bottom. And the H is what I'm missing. That's going to be the up and down. But I'm also given some other information that area is 68 centimeters squared. So I'm going to put the things that I know into the equation that I have that's a relationship with area for a trapezoid. So I know the area is 68. The top and bottom, my A and B, are 6 and 10 times h and divided by 2. I'm going to keep simplifying. Remember BEDMAS. I'm adding these together. 16h divided by 2. And then here, I can actually do 16 divided by 2. So 68 equals 8h. Just because that 2 divides evenly into the 16, I would divide it there first. And then to get h by itself, divide both sides by 8. So h equals 8.5. And make sure you put units where appropriate. This is measuring in centimeters, so the height will be in centimeters as well. Make this a little bit smaller so we can see it. Now the next one is kind of a linear relationship. Here we have the cost in dollars of producing yearbooks. We've done a lot with these, like cost of yearbooks, is 1,000 plus 5N. How much would it cost to produce 75 yearbooks? So just kind of a reminder here that we know C is the cost and N is the number of yearbooks. So this question says, how much would it cost? We don't know the cost, but we are given this number of 75, and that's how many yearbooks. So make sure you are kind of, when you see a number, make sure that you're matching that number up with the right variable. So 75 is the number of yearbooks, so that's the N. So C equals 1,000 plus 5 times 75. And sometimes it's as simple as this, and we just need to evaluate the formula. So plus 375 when I multiply, so 1,375. And I can write a therefore statement because this is about the number of yearbooks. Therefore, it would cost $1,375. The next one says how many yearbooks could be produced. So that's asking me to find N. It's find the number of yearbooks. And then this $4,000, that's the cost. So see how there's a difference here. You can't just guess where that number that you're given in the question goes. You have to be really careful and think about what that number means. The 75, that's a number of yearbooks. $4,000, that's a cost. So you have to put that into the right spot in the equation. So C equals 1,000 plus 5N. So here I have 4,000 equals 1,000 plus 5N. Now I have to rearrange. I'm going to do opposite operations to solve for N. So I'm going to subtract 1,000 from each side. So now I have 3,000 equals 5N. And then opposite operations is divide that by 5. So N equals, I think that would be 600. And then a therefore statement. Therefore, you can produce 600 yearbooks. So this one really highlights kind of two different parts, where one, we're looking for the cost, and I always like to kind of put that with a question mark to remind myself of what I'm looking for. And one, we're looking for the number of the yearbooks, so I put N as a question mark, just to remind myself that's what I'm looking for in my answer. For this one, you may want to pause and give this a try. Each week, Marissa withdraws the same amount from her bank account. Here's an equation that represents the amount of money in her account, which is A, and the number of weeks of withdrawing money, which is W for weeks. For how many weeks has she made withdrawals when the amount remaining is $110? So you guys can pause this and give this question a try, and then unpause the video when you're ready to check your answer. Okay, so again, just a reminder, we want to say A is the amount left and W is the weeks. So here's my formula. A equals 1,550 minus 90W. So this is a linear relationship. I see an initial, I see a rate of change, and we want to figure out a missing value. So when I look at the question, it says, how many weeks? I see that they're asking me about weeks. So that's my question mark. And the amount remaining is 110. So that goes in A for amount. So again, really be careful here that you're thinking carefully about the wording of the question and putting the number that you're given into the right spot in the equation. If you put 110 in for W, you would get a very wrong answer here. We want to make sure that 110, because it's the amount remaining, that goes in where my A is. So here, different ways to solve this. I know a lot of people don't really like the variables on the right hand side, so I might move that 90W over. Plus 110 equals 1,550. And the 90W here is positive. And then I'm going to subtract 110 from both sides. So I get 90W, those ones are gone. And this would be 1,440. And then divide out by 90. And W is, that's 16 weeks. So again, word problems always answer in a sentence. So therefore, she has $110, left after 16 weeks. That 110 is pretty messy. There. Okay, so answering in a word problem. And again, the only real trick here, this is a good review of our solving equations with our algebra, but we really want to be making sure that you pick the number to go in the correct spot based on the scenario in your question. Okay, last one in these examples. Whoops. Squeeze this down a little bit. So a waitress gets paid $10 per hour plus 15% of total sales in tips. Her pay can be calculated using this formula. So P is her pay, H is the hours worked, and T is the total sales. So we've got extra variables here. This is not just a regular like linear relation. We've got a pay variable, an hours variable, and a total sales variable. So let's see what we know and what we're looking for. So here, reading along, it says in 1 week, she worked 25 hours. I'm going to pop that in because that's very obviously the hours. And got paid $520. So this is $520. What were her total sales? What were the total sales? So that is, total sales is my question mark. So I think that doing this kind of summary off to the side can help you have the right numbers to put in the right spots in your equation. So here I'm going to have P equals 10H plus 0.15 T. So my pay, my total is 520, not 525, equals 10 times the number of hours plus 0.15 times T for your total sales. So now I'm just going to use BEDMAS, use opposite operations. I'm going to simplify here. 10 times 25 is 250 plus 0.15 T. Going through to solve this equation, I'll move the 250 over. That's gone. 520 minus 250 is 270. Equals 0.15 times T. And then to get T by itself, I'm going to divide by that decimal, the 0.15. And I get $1,800. So that's not money she made. That's how much she sold at the restaurant in like the meals that people bought. So therefore, her sales were $1,800. So you guys are all set now to go ahead and complete the lesson 8 homework. Again, you can go back and check this video, pause it as you need it to double check any of your answers.